Well, welcome. Welcome for those of you who are listening in. I'm going to share my screen. So, there we go. As Jada shared, my name is Kelly Hon, and I'm coming to you today from San Diego, California. A little bit about myself. I am married for almost 12 years to my husband, Ryan Hahn, and we met at Georgia Tech, where I did my undergraduate and graduate degrees in mechanical engineering. And I currently work for Becton Dickinson, BD. We are a global organization of about 75,000 employees worldwide. And as a mechanical engineer, like Jada shared, I am working on designing medical technology products for today and the future. I didn't grow up here in California. I grew up in the DC area. And not only did I move to Georgia for my undergraduate degree, but I also studied mechanical engineering in German at the University of Stuttgart in Germany. And eventually, once my husband graduated with his nuclear engineering degree, we moved here to California. So I'm not a California native, but certainly enjoying the beautiful sunny weather here. Outside of my work, I spend a lot of time volunteering at events like these, um, primarily with the organization called SWE, the Society of Women Engineers. We are just over 50,000 members worldwide, a global organization here to inspire, educate, and drive women in engineering forward to become the leaders that they'd like to be in their careers as engineers and technologists. Spent a lot of time in doing these types of outreach events. In fact, yesterday I was part of two as part of my birthday celebration, so that was a lot of fun. Outside of work and outside of that volunteer, I spent a lot of time outdoors, and I am a bit of an adventure junkie, and you can see some of those photos here on the right. So with that, I actually want to transition into the presentation here, and now that you know a little bit more about me, and start off with this concept of psychological safety. Some of you may have heard this term before, but for those of you that haven't, it is the belief that you'll not be punished or humiliated for speaking up. And a lot of times, we like to be in that safe space. And today, I want to hopefully inspire and educate you on how to get out of that space and why it is important for us to do that. The space that we want to be there is with respect to not only your thoughts, but also the things that you're going to be sharing and the concerns and your mistakes. So it's not just about the good, but also some of the challenges. Today, I'm sure you can relate. You don't want to look ignorant. You don't want to look incompetent. You don't want to be intrusive. You're not trying to be viewed as negative. And this is really easy to manage. You can stay silent and not ask your questions. You can not share any weaknesses that you have with others. You can keep quiet and not share up any ideas that you have or even critique the status quo. So it's pretty easy to stay in this state. But I want to challenge you to be brave, not to be perfect. I am a first child. I love having everything completely figured out before I go and answer that question, but rather challenging ourselves to be brave, to be fearless in owning the beliefs that we have, and allowing that self-doubt that's maybe creeping in to be silenced and instead feel that conviction of speaking up. Why is this important? Why am I challenging yourself to go out of that comfort zone? I'm going to share a little story with you. I used to work at a company called Knoll Brands where we have the hairbrushes, Goody hairbrushes. Maybe you also know their hair ties. And when I was working there, I was surprised to learn that the engineers who were designing our hairbrushes were actually three bald men. Now, imagine that picture in your head. Three bald men are having to design the next perfect hairbrush. Do you think that they could do it on their own? The answer is no. Maybe they'll come up with a hairbrush, but it's probably not going to be the best hairbrush if they don't ask questions. And so they do. They ask a lot of questions. Engineers, we're really curious people. And so we ask a lot of questions and we do a lot of research and we try and figure it out. So these engineers, they brought me to the room and they said, Kelly, we have this new hairbrush. What do you think? Now imagine if I didn't say anything and I let that design that was tangling up my hair, really pulling at my head, and I let that go into the market. That hairbrush would have not done very well and it wouldn't have sold many hairbrushes. So your voice really matters. And maybe it's not about a new idea that you have, but instead just speaking up and saying something isn't working, or even asking a question. And it's okay to ask them when people are working on something, a curiosity question, and finding out more about what it is that they're working on. So don't ever let this time be a space where you're withholding, because if you're withholding your thoughts or your information, you're really preventing the innovations. You're preventing the future world from having the best and most optimal product out there. And each of our voices and our experiences is unique. And so being able to bring all of those together to make the penultimate product is exactly what we're after. So continue to share those ideas. We can make stronger teams and stronger solutions together. With that, I want to walk you a little bit through my career journey. So, as I shared, I started off at Georgia Tech. And at Georgia Tech, in my engineering field, we did a senior design project, and I got to work with Delta. And I'll walk through that project in detail later. But in working through that project, I got to really work with industrial designers and mechanical engineers to build solutions. So that was one of my key moments in time as it related to my mechanical engineering journey. But the other experiences besides the classes that I took were also the internships. So I interned with a company called Amway, and I got to learn all about manufacturing. I worked on the Tresemme hairspray manufacturing line and got to learn, how do we make hairspray? How is that bottled? What is the manufacturing process? And how can we optimize that manufacturing line? And through that experience, it's kind of like how it's made. I really enjoyed learning about those principles, but I realized, you know what? I rather actually design the products than make them. And so I got my master's degree at the University of Stuttgart, all in product development and their life cycle. And I started my first job at Big Bang. At Big Bang, I worked with a lot of different people, thinking through designs. I worked on projects like designing the next coffee grinder with Hamilton Beach, or figuring out what is the best features of a mechanical paper towel dispenser instead of an automatic one. One of the key projects I worked on here, which I have an image of, is a sternal retractor. This device is used in open heart surgery. There's a bone in your body called the sternum, which is this bone right here in the center of your chest. And the doctors cut that one in half, and then they open you up to do and perform the operation on your heart. And today, those devices have a design that's been around for many, many years. And I got to work with that top heart surgeon to come up with a new design that would work in a different way, one that would minimize the amount of blood loss and let patients leave the hospital quicker. Today, those devices go in parallel. They open like this. But if you feel your bones, you'll notice that you've got some ribs that are lower down that are bigger than the ribs at the top. And so reality is that your body actually wants to open more like this, more like a butterfly versus parallel. And so this device enables that pivot to happen and the pressure of those of the retractor to apply equally along your ribs as opposed to at one focal point along those ribs, creating a pressure point. So this was a really fun project, a lot of iterations, some time in the OR, some time in the cadaver lab and the pig lab, and a lot of design and development. I then switched my career to a company that I had worked for before that I mentioned, a hairbrush story called Knoll Brands. Here I've designed stuff ranging from a device to take your cake or your cupcakes to a party, to a device that keeps the cleaning wipes for the cleaning people at the office organized, to a label maker. And that's the image I have here on the screen. And so as engineers, we often work cross-functionally with other individuals and functions. And so for me, as a mechanical engineer on this project, I got to work with electrical engineers and software engineers, in addition to other mechanical engineers. I also got to work with functions like industrial designers and marketing and project management. And so all of us together, we come together and we come up with these solutions. These solutions are ones that maybe get sketched out on a napkin and ideated on, and the industrial designers create images that I then turn into reality, making sure it can be manufactured by our partners, in this case over in China, and working with our electrical engineers to make sure they have the space for all their components, and then working with the industrial designers to also make sure that it's functionally and aesthetically what they're wanting to achieve. We then test our products through human factors and make sure that the users, you, use it how we intended, and we learn from those experiences. We thought you were going to open the product like this, and then you opened it differently. So how can we create better clues so that you know how to open things properly? After Newell, I switched here to Big BD, Becton Dickinson, and I've been working on medical technology products since then. I work on things like IV sets. Those are those tubes that go into your arm and deliver the drugs to you when you're in need. And this device here is for anesthesiologists. So those are the people who are trying to keep you asleep when you're having an operation. And so these anesthesiologists, they want to put you to sleep, keep you asleep, and then wake you up. And this device here enables them to have that control over the system and keep you in the state that you're needed to do, but change it on a dime. And so it's been a very interesting journey across all these different products, and I've learned a lot. And through that, I want to explain to you a little bit about the design thinking process. Do we have anybody on the line who's heard about design thinking before? I see a couple yeses and a couple nos. So we're going to walk through this process. So engineers, we move through these different phases of design thinking, and you can think about it from going from that blank piece of paper all the way to a final solution, an innovative solution. So on the right, you can see this um, figure eight, sideways figure eight or infinity symbol. And we start off with that define stage. So we figure out what is our exact problem? What are we trying to solve here? And we define that. Maybe we define that we want to take that cake to an event. We have a problem. We want to take a cake to an event, but we got to be able to hold a lot of things because I've got to be able to hold my keys and open up the door and put the cake in the car. And the cake needs to stay safe when I'm driving. And then I need to be able to bring it into the event. So I define my problem statement. And then I go and I empathize. I go and try and understand the people. Maybe it's not only me that needs to take cakes to parties. Maybe it's my grandmother who needs to take cakes to the party. Maybe it's my dad. Maybe it's a young child who needs to be able to bring cakes to their birthday parties with their friends. So we go and we try and understand those people. We maybe follow them around and see what happens. What are the different things that they're holding? What are the different car doors? What are the heights? What are the rooms and the spaces? And what are the events that they're taking them through? So we empathize. And from there, we ideate. We come up with ideas. How can we solve this? What would it look like? Maybe it's a device that holds with a single hand a handle. Maybe it's a device that I can somehow put underneath my arm and hold in that way. And so we start to sketch out ideas and come up with solutions. From there, we maybe down select and prototype. And prototyping can be with some cardboard at home or maybe 3D printing if your school has a 3D printer. And we base together some solutions, and then we go and test it. We maybe hand it to those people and say, hey, could you give me some feedback on this concept and design? Maybe you yourself give it a try and see what you learn from it. Maybe through that process, you'll learn, okay, well, I forgot to include a feature where it keeps the cake in the middle of this device, and my cake went all over the place and the frosting got all destroyed. So we learn things through this process, and then we start the cycle all over again. So we say, okay, did I define my problem statement correctly? No, I forgot to include this aspect of keeping the cake centered and not getting frosting all over the place. And then we go and we understand more about what are those other parameters that maybe I missed. And we ideate and prototype and test again. This entire design thinking process, as you can see in the bottom right, is all about framing that question, gathering the inspiration, generating ideas, making some tangible ideas, testing to learn, and then in the end, we have our product and we get to share our story. Design thinking is an important step, and I'm going to walk you through my specific example of this cart that is on airplanes. So today, back in the day, I actually worked on this project for Delta, and flight attendants, they push a cart with food and drinks to be able to give them to the customers on the plane. And these carts are very heavy, and airplanes fly at an angle. And sometimes airplanes experience turbulence, which means that they're moving around a little bit more jostling than usual. And these carts are very heavy, and sometimes when they're placed in the galley where they need to set them up, they were falling over because of the turbulence. And flight attendants were trying to catch them. They were catching them with their hands and their bodies, and they were injuring their wrists and injuring their knees. And so they said, "Hello, Georgia Tech engineering team, can you come help us figure out a solution? We can't redesign the whole cart, so we need a solution." So they gave us their problem statement, and we start with the framing of the question. Why are flight attendants getting injured during flight? And how can we prevent this? We then went and got that inspiration. We defined it. We talked to flight attendants. We even took a flight and we observed them. What's going on? How does this happen? How are they? What are the different things that we can learn about the motions that they do need to take? We then ideated. We came up with lots of solutions. We had our parameters in mind and we said, okay, how can we solve this problem from multiple angles? Not just maybe one solution, but maybe diving deep into one solution with myriads of opportunities, but then also a variety of solutions. And then we prototyped. We built some 3D rough prototypes that we later defined. And you can see those in the bottom right. And then in the end, we tested that in a flight simulator with our flight attendants to say, hey, is this working? Is it good? Do we like it? Are there other refinements we need to make? And so this device on the bottom right, today, when a cart, we learned while we were watching them, when the carts start to tip, the caster wheels start to rotate inward and they move their center of gravity of this cart and they put them in the worst possible situation. And the cart, once it starts tipping, it tips even faster because of this. And so we added this foot onto the caster wheels that changes that focal point from what was previously in the middle of the cart to being outside of the cart. And by doing this, we've changed that location and it's able to catch the carts from falling over. So this is an example of design thinking in practice, and hopefully this inspires you as you work through some problems that you're experiencing today and finding solutions as they go through. As we come to a close, I want to leave you with this quote from Queen Elizabeth II. At its heart, engineering is about using science to find creative, practical solutions. And today, what we do is really a noble profession. We come up with solutions to all sorts of issues out in the world, and we're making them go away through our solutions that we come up with. So, engineering is a very powerful, superhero-esque role that we have. And I hope you will speak up to come up with your solutions and share your ideas because they themselves will help us move into a brighter future. And with that, I'll wrap it up to remind you that you can be it and you can do it. So please leave this session hopefully with an inspiration to not only progress in your careers, maybe as STEMinists, STEM professionals, but also speaking up in your roles here as individuals with unique experiences, unique thoughts, and unique opportunities that I'm sure you'll make the most of. Thank you so much. I'll now open up the floor for questions.
I had a question. So how did you know that you wanted to go into engineering and specifically product design? And were there any like experiences as a child that you had?
Sure. Thanks for the question, Jada. So, I always wanted to be a race car driver when I was little. And I had a go-kart and I enjoyed going fast and I enjoyed being in the car. Sometimes my parents, they would say, you got to go out and play. And I said, give me the keys to the car. I'm just going to go sit in the car and come up with my own games. And so I thought I'd be a race car driver, but in the end, I ended up having to get contacts. And in order to be a race car driver, similar to a pilot, you need to have very good eyesight. And so I said, well, you know what? If I can't drive the cars, maybe I can engineer them. And so I thought I'd go down that path. And in exploring different opportunities, I learned about mechanical engineering. I had also taken an aptitude test in high school where they tested me on all sorts of different things. Like I needed to pick up these little pins and move them from one hole into another. They had a piece of paper that they had folded four ways and an imaginary piece of paper, and they put holes in it. And they said, okay, if you open up this piece of paper, where are the holes? I had to memorize 20, I think it was 20 license plates and be able to in 2 minutes. And then I had to be able to tell you how many of those I still remembered after 5 minutes. So we did this aptitude test and they said, wow, you have a lot of spatial reasoning skills. And so you'd probably be good at engineering or architecture. And again, having that background and that interest, it just made sense. Engineering, I said. And it's also a lot of people in my family on my mom's side. We actually do have some engineers. I have some aerospace engineers, aeronautical engineers, and there's a mechanical engineer on that side of the family. Now, my mom, she probably would have been an engineer too, but she didn't know about engineering at the time or wasn't really forced in that direction. But I now had that opportunity. And so I picked mechanical engineering. It's a very broad engineering field because I didn't really know exactly what I wanted to do. I thought maybe cars, but I went to Georgia Tech and I said, wow, I really don't know a lot about cars. This is probably not the right thing. And so that's why I did all those internships. I interned in HVAC, so that's the heating and ventilation and air conditioning. That's a super traditional mechanical engineering role. And then I worked at that manufacturing facility on the Tresemme hairspray, like I said. And then the next internship, I worked on strollers, and I have a patent on folding mechanism for strollers. And so I said, oh my goodness, I really like this experience of designing the products. And so that helped me progress in this career of product development. Does that answer your question, Jada?
Yeah, thank you. And
Yeah,
does
my pleasure.
anyone else have any questions?
To hear about your journey and the products that you have developed that has a real world implication. So a lot of these students that I work with do not understand what could be some of these very simple minor problems that they can see and they can solve.
That's right.
So my work here is to help these kids understand problems that you see at home every day, you don't even think about as a problem, but you can design something that
Yeah.
can definitely shift the whole paradigm of, how things work. So every time I'm on a flight, I always figure out that I need to develop something to rest a head like this, and I've designed a prototype. It's in a provisional patent application, but you know, things that they can do. So these
That's
students, actually, 9 students already have patents.
that's
And we have
great.
15 patent pendings on things like that, small things that they work with. So my work here, Kelly, is to motivate these good kids. And I just sent a message to the SWE group that I need more people. I need more mentors like you who would help these students identify not just problems, but how to come up with a design that can be patented. Because I work on the patent side with USPTO as well. So we are working on a framework for under 18 programs where we are working to have these students with a mindset that, yes, they can be problem solvers. They don't have to be official doctors or engineers to wait to expand their curiosity and problem solving skills. It can happen really, really early. So
That's right.
yeah, I've already sent you a picture to them as well as a message like, hey, thanks, Kelly, for doing this. But
Perfect.
I truly appreciate it, Kelly, and I will
Oh,
look
of
forward
course.
to,
And not everything that the students are working on is necessarily needing to be patent
oh
worthy.
no,
We
yeah,
talked about in our first session too about causes that are close to your heart. And
yeah,
there was one student who's really interested in reducing carbon footprint
yeah,
and figuring out how can we maybe do that from an
absolutely.
environmental engineering perspective. And so solutions that we come up with are things that maybe we want to implement right away, which is really cool, and we can do in our own ecosystem. And maybe there's things that already exist today, they just haven't been implemented across the globe. And so we have that
Yeah,
opportunity to bring those solutions to light in new and different environments. Yeah,
absolutely. Absolutely. I agree. I'll connect with you more outside of this as well, Kelly, for sure.
that's good. Yeah,
And then I have a question for the students that are here, and then maybe for students who are going to be watching this later.
yeah,
Uh, I think that might be helpful. I know a lot of students are they kind of zone in on this idea that they need to know everything, right? They need to know how uh, all the mathematical equations or have a really strong knowledge in physics, or they need to have a really big breadth of knowledge already before they can even start to think about engineering or coming up with an innovation. Um,
yeah.
how can you, or can you please go through and kind of assuage some of that concern, or
Mhm.
kind of tell them how to combat that?
Sure. So I did a volunteer event yesterday where we were building towers. You maybe have done that before, where we're using some paper, and somehow just paper alone is going to hold up textbooks, and it's super
Yeah,
incredible to see. And so a lot of times, similar to what you're describing, Sarah, is our students are letting their minds block them before they even start something with the paper. And so as you saw in that design thinking process, there's a little bit of thinking and defining the problem, which you have sometimes already in front of you, but then getting into that testing stage. And so I really encourage people to try things out, ask more questions, and surround yourself with people that think differently. And those people may be able to also help you in that process, right? And so just because maybe you don't have a skill, like I don't have a skill in software engineering or I don't have a skill in electrical engineering, but I've built relationships with those people and I ask them questions so I can understand why is this a parameter so that I can then make sure I've got my problem statement right. I can build around it, but maybe I can also learn a little bit of the electrical engineering or the software engineering in the process. Doesn't mean I need to be an expert. I need to know enough to be able to ask good questions, and be able to take the information that they provide to me and have it as an input to what I'm working on. But yeah, my guidance to you all is to go try. Don't let yourself be a limiting factor, similar to what we talked about with that psychological safety at the beginning. Don't let yourself create these doubts or questions in your minds. Just go start and try it. And it's okay if something doesn't work out. Failure is no, it's not such a thing. I talk about there's either you win or you grow. So either you're going to win and solve that problem or you're going to grow through the process. And so view it as that way, as not a positive or a negative. all of it is going to be positive in the end. And I think that's what really is helpful as you go through these processes, because throughout it, I know you're going to learn something, even if it's knowing that that doesn't work. So continue down that path and trying. Does that help answer your question, Sarah?
Oh, it's perfect. Thank you.
My
I
pleasure.
appreciate that.
Yeah.
And one other thing I wanted to emphasize here is that I have seen a lot of these students, and I used to work at high school for at least 8, 9 years, and even in middle school kids, they are not even conscious of the biasness that come with it because of their cultures,
Hmm.
right? So they grew up in a very specific way, and they are very ignorant of this is supposed to be this way. I'm like, no, think
Yeah.
about other ways to solve that same problem, which is outside of your comfort zone, which is okay,
Hmm.
and
Hmm.
just that realization has got these kids to such great steps going ahead
Yeah.
and empowering them. It's phenomenal. It love what everybody can do together when we can expand that mindset of
Yes. Well, and I
students
think that
thinking,
kind of brings back to that hairbrush analogy, right?
yeah,
And that your bias and your experiences are also a good thing, because I know my experience with the hairbrush, and I have this type of hair, but Jada has different hair, and
yeah,
you have different hair, and so each of us providing that feedback to someone is going to be different, but also good feedback, and together we will then make maybe one perfect solution, or maybe we need to have multiple solutions. And so being cognizant of the background that you do have, and being aware that your experiences may be different than others is a really important thing to be conscious of, and to continue to do that, speaking up, because just because one person has an answer that does work, it maybe doesn't work for everyone. And we do have those biases that come into play, where maybe I'm going to go ask people that look like me. So I do encourage you to surround yourself with people that don't look like you and don't think like you. And when I say that, I say maybe people that go to a different school, maybe people that spend more time on in the creatives. So you heard me talk about I enjoyed working with industrial designers, and they tend to use a lot more of the other side of the brain than I do. And I'm very maybe logical thinking, and they're more empathetic thinking. And so surrounding ourselves with people who have those different biases themselves in ways of thinking is really great. And so when we diversify who we're working with, maybe we expand our circle a little bit, we're able to come up with the better solutions.
thank you, Kelly.
Yeah.
Another example of that is what I think about when we're thinking of solutions. You can think about the sidewalk. Today, the sidewalk was designed with those ramps, and those ramps are designed for wheelchair. But think about all the different people who benefit from those ramps. We think about maybe a mom with a, or a dad with a stroller. We maybe
Yeah,
think about a grandparent with a walker or a cane. We think about our blind partners who need to be able to find an exit without falling. You may think about a kid on a bicycle. So there's so many different people who,
yeah,
when we design something, and if we design it well, will actually have a trickle effect of having assets and benefits for other people beyond the demographics that maybe were in our problem statement.
exactly,
So pretty cool to
exactly.
see that too.
Yeah. Zeta, I think you have a question.
Um,
Or Panjai?
yeah, I have a question. You have talked about your internship, your work experience. Can you talk more about like when you were in high school and college, and maybe like towards like high school towards college? How did you spend your time and yeah,
Yeah.
curriculum activities? Yeah.
Sure. So
Yeah.
I went to a liberal arts high school, more liberal arts focused, so not so STEM focused. I spent a lot of time outside of school playing sports, but also learning languages. So, like you saw in my background, I speak German, but in high school I learned French, and I studied abroad in France then. And beyond that, my physics teacher was the one who really introduced me to engineering. And so she encouraged me to go to some conferences and speaking opportunity, not for me to speak, but for other people who spoke to me. Growing up in the DC area, it exposed me to some of the firms in our military that are located there, and being able to go to some sessions that they have hosted for high potential students. And then in the summertime, I went to summer camps. I remember learning about fire engineering and how somebody designed in a building the different spacings associated with the sprinkler system. And I learned about traffic engineering and how we figured out the lights and the timing of the lights to make sure that the traffic flows properly. And I got to play with the Lego robots and solve a problem with having the robots do a certain pattern in motion. So I would encourage students to not take on too many activities, to prioritize what's important to them, to similarly to test out maybe this thing you enjoy and this thing you don't enjoy, and it's okay to say you don't enjoy that and move on. But if there's something that you enjoy, to try and maybe dive a little bit deeper into that and to find out a variety of opportunities where you can be exposed to that. First Robotics is an example on the robotics side that people can get involved in from a club's perspective. This HerCatalyst, SWE is a club that you can get involved in to get exposure. Girl Scouts, Boy Scouts, or others outside, but equally any place where you're on a team. So that could be the drama club, that could be the sports team, that could be in your band. Each of those, you're a part of a team. And I think in the end, it's about learning how to work together, how to come together and perform in whatever that looks like for that group and deliver to the top of your ability. And so in each of those endeavors, you're going to learn those skills. So it's okay to diversify. Everything doesn't need to be about STEM. You'll still learn a lot through each of those experiences about how to be a leader. And in the end, we are all leaders, and we need these skills to be successful in life.
Thank you. Yeah, I think our
Yeah,
meeting will end soon, but I really appreciate you coming to talk, and
my
all of your
pleasure.
insights were really, really good to take into consideration for our future. Thank,
Yeah. Thank you for having me.
thank
Bye
you.
now.